Welcome. In this video, let us understand the working of a rectifier. So here the circuit diagram, input waveform and output waveform are shown in the figure. We know that the rectifier converts AC signal into pulsating DC, and the half-wave rectifier converts one half of the AC cycle into pulsating DC. So the circuit diagram of half-wave rectifier consists of a step-down transformer, diode, and a load resistor. The input voltage is represented by the equation Vi equal to Vm sin omega t. Vm is the peak value of the input signal. The input voltage is nothing but the secondary voltage. This is the input voltage Vi. The secondary voltage of the transformer acts as the input to the rectifier circuit. The secondary voltage of the transformer is the input voltage to the rectifier circuit. The input signal, if you observe the waveform, input signal has positive half cycle and negative half cycle. Now let us understand the working condition of the half-wave rectifier. During positive half cycle, the terminal A is positive with respect to B. Therefore, the diode is forward biased. And hence it conducts. During positive half cycle of the input signal, this is terminal A positive and this is terminal B is negative. So the diode is forward biased. To make the diode forward biased, the anode of the diode, this is the anode of the diode, is connected to positive, and cathode via resistor, load resistor RL, is connected to negative. Hence the diode is forward biased. During positive half cycle, the terminal A is positive with respect to B. Therefore, diode is forward biased. Hence, the diode acts as a closed switch. So, the diode is replaced by a closed switch. So, terminal A is positive and B is negative. Hence, the diode is forward biased and it acts as a closed switch. So, this is the equivalent diagram during positive half cycle. Therefore, there is a flow of current from the transformer secondary through resistor RL. So, there is a flow of current. Through resistor RL, which develops a voltage across the load. The output voltage is same as the secondary voltage, that is the input voltage. During positive half cycle, there is a flow of current through the load resistor which will generate the voltage across the load. Therefore, the output voltage is same as the input signal. Now let us consider the negative half cycle. So during negative half cycle, the terminal A is negative and B is positive. Hence, the diode is reverse bias. It acts as a open switch. So during negative half cycle, so this is the equivalent diagram. Diode is replaced by a open switch. The circuit is open during negative half cycle. There is no flow of current through RL. Hence, the output voltage is 0. During negative half cycle, there is no current through load resistor RL. Hence, the output voltage is 0. This is the input voltage. During positive half cycle, this circuit will produce the output voltage, the pulsating DC. During negative half cycle, output voltage is 0. When the cycle repeats, we will get again positive half cycle. It produces output voltage. During negative half cycle, output voltage is 0. Now let us summarize the working of half-wave rectifier. During positive half cycle, diode D is forward biased and it conducts. That means it acts as a closed switch. Hence, the output voltage is same as the input signal. During negative half cycle, the diode D is reverse biased and does not conduct. That means it acts as a open switch. As there is no current through the load resistor, output voltage is 0. The average output voltage, which is called as DC voltage, is given by the formula VDC equal to Vm by pi, which is equal to 0.318 Vm, where Vm is the peak value of the input signal. This is the Vm value, the peak value of the input signal. The average value, DC value, is represented in the output waveform, which is equal to 0.318 Vm. Let's consider the advantages and disadvantages of half-wave rectifier. The half-wave rectifier circuit is simple. The circuit is very simple and easy to construct. Half-wave rectifier is inexpensive because it has got few components. The disadvantages of half-wave rectifier are there is a power loss. There is a power loss in half-wave rectifier because half-wave rectifier converts only one half of the cycle, which is based on the direction of the diode connected in the circuit. So there is a power loss because the output voltage is low. There is a wastage of power. As the output voltage is low, the rectification efficiency of half-wave rectifier is low. In half-wave rectifier, transformer utilization is also low. Half-wave rectifier has high ripple factor. That means the half-wave rectifier has more AC component in the rectified output. Because of all these disadvantages, we use full wave rectifier. Thank you.